Hey, what's going on, guys? Today I'm going to be talking about how many coolant repairs I've had to do on my 2013 Escape over the last 10 years. We've put 130,000 miles on it. We bought it with about 58,000 miles, so we're right around that 180,000 mile mark. So we've had to replace a lot of things related to the coolant. Luckily, we've never had the coolant intrusion issue on our 1.6 liter EcoBoost, but we have had a slew of other things. Some things have been easy to replace, even if they've been frequent repairs and having to redo them. Others have been royal pains in the butt. The point of me doing this video today is to show you the things I've run up against to help you troubleshoot if your Ford Escape is having coolant issues. Let's get started. So looking into our engine bay with the wiper cowl off so you can see everything, I'm going to go to the first and foremost thing that I've had to replace the most here, and that's this blue guy here. This is the Coolant Bypass Solenoid, and if that fails, it'll give you code P26B7. If you need to replace it, it's not a big deal. You need to put a pan under your car. You take off the bolts that hold it up against the coolant outlet flange, and then once it's disconnected, you can use a hose clamp tool to take off that clamp, and you swap it out after you disconnect the electrical connector, of course. Not a bad deal. They're not that expensive. It's just annoying because it happens once every couple winters. And if you're used to dealing with coolant issues, you need to buy one of these. These are coolant remote hose clamp pliers. They ratchet down, and these two little teeth here pull on the tangs of the hose clamps. That way you can get it in the right spot. You clamp it, ratchet it down, the hose clamp gets stuck in the open position, and then you wiggle the hose off. This is not an expensive tool, and it saved my butt on many occasions. Same area, what I've had to replace twice is the coolant outlet flange. And that is the piece that the coolant solenoid bolts to, which is this. So these two brass inserts here are where the two screws for the coolant solenoid goes into. But what's failed on my outlet flange is the flange here for the water outlet at the end of the block. There's an O-ring that goes around here that achieves the seal, and when the ridge on this flange fails, the O-ring disintegrates and coolant leaks all out the side. I had to find out where the leak on this thing was with a coolant pressure test kit, and if you haven't used one of those before, they're also a lifesaver. You can go to Advanced Auto or a local auto parts store and rent one. It's a huge aid in finding the leaks. Next, I've had to replace the coolant overflow line going to the tank because this line is very long. It runs along the inside of the engine bay, works its way around, wraps around the back of the block, and also forks and goes into the radiator as well. As it wraps around here, the part that I replaced here ran all the way back, and it was all this narrow plastic, but the replacement part with the updated part numbers and details came with this rubber hose. So my guess is that was to battle the heat and to not have the line get so brittle, because when a plastic line gets heated up and cooled down repeatedly, it gets brittle and then it cracks under pressure. Now this next one here took a long time to figure out. There are these hoses here that go into the heater core in the back of the firewall, and you can see that white plastic tab there. That's Ford's cutesy little quick disconnect, and that thing caused me the biggest headache. I had that part of the hose degrading, and it was dripping down onto the aluminum shield down there. And I couldn't tell where it was leaking from, and I would see steam coming up as that coolant was evaporating, and I thought it was much worse than it really was. So those connectors are tough to get to, and it's really hard to get the proper leverage. There's a special tool that they have that's very cheap that will give you better leverage, so check this out. This here is a little adapter tool that just lets you get a better grip and distributed hold on those plastic tabs, because if you just grip them and twist, you'll break the tabs right off and the whole thing's shot. So what this does is it slides on over those plastic tabs. You can grip the whole thing, and it holds on to both sides of the connector, and you twist it to unlock it. So very helpful, again, very cheap, but good tool to have. We were just looking at the two heater core hoses going into the firewall there. Well, that heater core hose comes over here and connects to another one of those on top and bottom hoses with these plastic tabs. But I also had this three-way hose here fail and start leaking, so we've had to replace that one as well. So these little plastic connectors, even if they don't look worn out, if you disconnect them, the male ends that go into the sockets for the twist lock, they degrade and have like chunks missing and stuff, and it makes you wonder kind of what's going around in your coolant system in there. So I replaced this three-way hose because this one was leaking as well, along with that heater inlet hose there. I have one more thing to share about the coolant system that I've learned. It's not necessarily specific component related, but if you ever are in the case where you've drained the coolant out of your engine block, at least with the 1.6 liter engine, there's the thermostat at the coolant outlet flange, and you need to get coolant to that thermostat before it shuts your engine down in limp mode. So if it throws the code saying overheating issue, but you know there's coolant in the reservoir, what a service tech told me to do was use an OBD2 scanner, erase that code, disconnect the battery for 10 minutes, connect the battery, and then when you start the car up, you are in a race against time to get coolant to that sensor before the sensor sends your car back into limp mode. So hold the engine in park, of course, at 3,600 RPM for, I think it was 2 minutes. That way it gets the air pushed through the system, gets the coolant to that sensor, and then once you have coolant at the sensor and it's not timing you out for over temperature situations, you go back and keep adding coolant to the reservoir until it's at rest at that max min line that you see on the front of there. So that was a roundabout way of explaining that, but I hope it wasn't too confusing. This car's full of sensors and it's made to protect the car from getting hurt, but the reality is that it's complicated a bit too. So let us know in the comments down below if you've had any issues like these or different ones that have been recurring issues with your Escape. And if you have any questions about this, also drop a comment and check out the links to the tools that we recommended in the description below. Thanks for watching How to Escape. We'll see you next time.